The first conic section we're really going to dive into is the parabola, and this is one that you've seen before. Back in earlier algebra classes, you've studied parabolas in the sense that they were the shape that a quadratic equation formed. So they either opened up, they could have opened down, depending on whether it's a positive x squared or a negative x squared. So we studied these in the sense that they are quadratics. We want to expand our definition because parabolas can not only open left and right, open up and down, but they can also open left and right. And then once we get into rotations, they could actually open on diagonals as well. They don't have to open strictly up, down, left, right. But for today, we're going to concentrate on just these four basic directions, up, down, left, right. And we want to go beyond our definition in algebra to really understand what is a parabola. It's not just a quadratic function, but it has some inherent properties. So let's start with the definition. Parabola is the set of all points in a plane equidistant from a fixed line called the directrix and a focal point or a fixed point called the focus. So I'm not a good drawer, as you guys have come to realize by now, but if I fix these two items, so we have our directrix, this line here, and our fixed point called the focus, well then I'm going to look for equidistant points from both of these two things. So obviously the first point has to be in the dead center. That's the same length as that right there. Now, if I were to come out to a point, say, over here, let me switch to green for a second. If I have this green length, that has to be matched by this red length. And so we can see right now they would not be the same, so it's probably going to be a little bit further in. So maybe right there would be our next point. Let me change that over to black. And so we can see that the green line and the red line should be of equal lengths. And I would continue doing that. So if I'm way out here, if I take a distance, then that green distance has to be the same as this distance here, so I need to go a little bit further. And then probably right in there, those two green and red lines appear to be more or less the same. So we can see that this one is has quite a swoop to it. It does not turn very sharply because the focus and the directrix are relatively far away from each other. So that is what a parabola really is. So there's a couple of definitions that you had from quadratics, or at least a couple of formulas. And so you had the general form and the standard form of a quadratic. I'm going to write these up here, but I want you to immediately forget them, and not really forget them, but we're not using these anymore. We're not looking at quadratics, we're looking at parabolas. So we're going to define these a little bit differently. So with our general form, we had the x squared plus bx plus c, everything's set on one side. Now that's actually going to be pretty true of the parabola as well, because general form always means it's all multiplied out, it's all on one side. So that's going to be relatively the same. Our standard form, however, that's really what we're going to concentrate with all these conic sections. The standard form tells us some is. So just like in quadratic equations, we could very quickly read the center to be hk, or I shouldn't say the center, but the vertex. The vertex being the point where it turns, that was the point hk. We're still going to have a vertex. Clearly, it doesn't matter if it's opening left, down, up, right. It's still going to have a vertex, but we're going to find that slightly differently. And then the a told us whether it opened up or down, and we're going to have some other information when we come to the standard form of parabolas. So again, don't necessarily forget these, but we're not actually going to use these in this class. So don't ever write these on your paper again in trig. So here's the standard form of a parabola. X minus h squared equals 4p y minus k, or notice now we have a second one as well. These are both the standard form. Y minus k squared equals 4p x minus h. Now, why might it be that we have two different forms when before we only had the one form of a quadratic? Well, the quadratic was a function that had to open up or down, versus we've just said the parabola can open up, down, or left and right, and that's where we get this second equation from. We also have the possibility that it opens left and right. So how do we know which one does which? Well, here we see the x being squared. We've seen that before in the quadratic sense. And so this is going to be the one that opens up or down. I'll talk about which one it's going to be in just a second. This one here, y squared, is not a function. So that's going to have to be the one that opens left or right. So again, they could be doing the opposite thing, but I'm just getting the idea on my paper right now. Now, there's a lot of information that these give me very quickly, and so one of the first things is whether it does open up, down, or left, right, and the p is going to tell me that. if the p is greater than 0, meaning the coefficient is positive, it's going to open up. That's very similar to the A before, but again, we're kind of breaking with those definitions because the p is going to mean something very different in just a second. If the p is negative, it opens down. That's for the x squared version. If we have the y squared version, if p is greater than 0, it's going to open to the right, the positive direction. If p is negative, it opens the negative direction, opens left. Okay, so we have our two different cases here. P does tell us a little bit something extra, so I'm going to pause on that for just a second and talk about the other thing that we knew before, which is the vertex. The vertex is the point HK. H is with the x, the k is with the y. Here it's the exact same thing, still HK, but notice H and the K are now on opposite sides. Whenever we're putting something into the standard form for the parabola, we want the squared term to be isolated along with its x coordinate of the vertex or the y coordinate of the vertex. Everything else is going to be moved to the other side. So it doesn't matter what's on left or right in terms of the vertex, it matters what they're attached to. So the H is always attached to the x, the K is always attached to the y. Now, that P does give us something different. If we remember how we defined the parabola, it was this set of points equidistant from the focus and the directrix. And so that's what we're missing with the quadratic format. We were not ever able to see the focus or the directrix. And so we're going to add in those pieces of the puzzle. And so the focus and directrix are both going to rely on that letter P. That P is going to give us the distance from the vertex to the focal point. So this red distance in here. And it also gives me the distance from the directrix to the vertex. And remember, they have to be the same. So that P is the distance from the vertex to the focus or from the vertex to the directrix. Now, how do I know which one I'm going to? Well, it all has to deal with that P being positive or negative. I said distance, distance ignoring the sign, right? Just thinking about how far we are. The P will actually always correspond directly to the focus. The P will always take us from the vertex to the focus. If we use the negative direction, it will take us to the directrix. And the same thing is true regardless of if we're going left, right, or up and down. So that distance P still from the vertex to the directrix or from the vertex to the focus. So that red distance in there. So our focal point, we started, if we think about it opening up and down, we started at this point HK. We have to travel by P units, and we can see that we're purely traveling up. And so we'd have the point H, comma, K plus P. If we're thinking about the one that opens left and right, we're starting at the vertex, but this time we're traveling right, so we're going to have to take that P and add it to the H coordinate. And then the directrix, well, the directrix is a line, not a point, so I need to make sure I have the correct format of the line, and if it's opening up and down, we can see it's a horizontal line. And so a horizontal line always has the format y is equal to, and then the y value used to be, for the vertex, was at the value of k, but then we had to travel by a distance of p, the opposite direction we went from the focus, so we're going to have k minus p. If it's opening left and right, well, now the directrix we can see is a vertical line, so that's going to be x is equal to. And rather than traveling by p direction, p units in p's direction, I'm going to travel the opposite direction, so h minus p. So these are all the key characteristics that those h's, k's, and p's give to me. I can see that's a lot to have to remember. If you just want to strictly memorize the table, there it is. That's a pain in the butt, though. That's a whole lot to have to remember. I'm going to show you, think about them more in terms of what the values mean, not just trying to put them into the formula. Because if we truly understand what the h, the k, and the p mean, we don't have to memorize any of this stuff. We're just going to place it according to what the numbers are. One last thing that these do tell me, and that is the length of the lattice rectum. So, bit of a funny word, but It is what it is. That gives the thing that I'm missing right now is I don't have any idea how wide this thing is. And I ran into that problem when I tried to draw it, trying to freehand these things, making sure these were equidistant. That's very, very challenging. It's much easier to have a known length across the parabola. And that's what the length of the last rectum does for me. The length of the last rectum is always equal to 4p, and it's the absolute value of that. It doesn't matter if it's opening left, right, up, or down. And that's going to give me that distance across the parabola at the focal point. So again, let me draw a bigger parabola off here to the side. We have our vertex, wherever that might be. We have our focal point p units away from the vertex. Well, 4p, so you can see I don't have this drawn very accurately. That should be 4 times as long. 4p would be the width at that point. And so that allows me to figure out how wide these things are when I'm actually drawing them out. So let's take an example and let's put it all together. Let's take the function f of x is equal to, sorry, can't call it a function now because we don't know that it's a function. Let me change my my notation. Let's take the equation, not the function. Let's take the equation y minus 2 squared equals 8x plus 1. And so the first thing I'm going to do is I'm actually going to start with a sketch just to kind of help me get ideas on paper. I see this as a y squared, and so that's telling me what I said just a second ago. We don't know that it's a function. In fact, this one is not a function. This one's going to be opening left or right. And that p, whether this coefficient is positive or negative, tells me which way it's going to go. So because this is positive, that does tell me it has to be opening to the right. So everything I do is going to be based on this thing opening left and right. Next thing I'm going to do is figure out where that vertex is. Well, the vertex is the point hk. Remember, the h is always with the x, so the k is always with the y. So I have to use the opposite of the value, so I'd have negative 1, positive 2. So I now know this would be at negative 1, positive 2. Next thing I need to get is my p-value, because the p-value tells me how to get to all the other points. Remember, this coefficient is not equal to the p. That is equal to 4 times p. So I'm going to set up the equation 4p is equal to whatever that coefficient is. That's always what I'm going to do. 4p is equal to that coefficient. Then if I divide both sides by the 4, I found out that my p is equal to 2. And so that's going to help me go from my vertex to my focus and from my vertex to my directrix. So if I were to start at my vertex, I'd have to count clearly to the right to get to my focal point. And now I know I have to count by 2 values, 2 units. So I'd have negative 1 plus 2. The y value is going to remain unchanged. And so I can see the focal point is actually 1, 2. Next, I'm going to move on to the directrix. The directrix is always equal to a line, or it is always a line. In this case, it's going to be a vertical line. We're going to have to go the opposite way that we went to get to the focus. So I started at negative 1. Before I added 2, this time I'm going to subtract 2. And so then I see I get the equation x is equal to negative 3. So I now know this passes through negative 3. And there's my directrix. Now this picture is not very well drawn to scale because clearly the directrix is too close. We'll go back and fix that in just a second. But the last thing I really need to do to fix that is get the length of the last rectum, which I'm going to abbreviate LR. And so I'm going to take 4 times my p. Well, that's exactly what that coefficient was in the beginning, with the exception of if it's ever negative, we have to make it positive. So whatever that coefficient is, will give you the length of the last rectum. Now I'm going to put it all together to get a more accurate picture, because this first one was just a ballpark. This is not a very accurate picture. So I'm going to start by going to my vertex. That was at negative 1, 2. And the other thing I'm going to do is I'm going to label just with V's, F's, D's as I go along. It's going to make it easier for me to figure out what point is what, because we have a lot going on these pictures. Next I have the point 1, 2. That's my focus. My directrix balanced on the other side. Now these two things should be equidistant, so that point got a little farther away. Let me try and make that scale a little bit better. Easier on graph paper, obviously, but these two things should be balanced now. And then I know the distance across the parabola at the focus, and that distance is 8, so go down 1, 2, 3, 4. So that'll be the side of the parabola. 1, 2, 3, 4. That'll be the other side of the parabola. And so I know my parabola now looks like that, and I have my directrix over here as well.